Good morning, everyone. How are you? I hope you are all doing fine. In yesterday's lecture, we talked about the stars in general, and we talked about the characteristics of one of the most important stars that we have, which is the center of our solar system, the Sun. In today's lecture, we are going to make a quick revision about the Sun, and we are going to talk about stars in general. So let's start. As a revision, we talked and we said that the Sun is a fiery ball of hot gases with no hard surfaces. It gives off enormous amounts of thermal energy and light energy. And we said that the layers of the Sun are divided into three parts. The innermost layer is called the photosphere, and as a definition, the photosphere is the innermost part or layer of the Sun, and it gives off the light energy that we see. So the innermost part or layer of the Sun's atmosphere is called the photosphere. So it's here deep inside. The second layer or the middle layer is the chromosphere. The chromosphere is the layer of atmosphere above the photosphere, and it's below the corona. So this is the chromosphere. To move out, we have the corona, which is the outermost layer of the Sun's atmosphere. We can see it's there. So this one is the corona. And we talked about the sunspots. And as the name suggests, the sunspots are dark spots found on the Sun's surface. You can see here, like these dark spots. So they are part of the photosphere, which is the outermost layer. The number of sunspots change in cycles of about 11 years. We have the prominence, which are the prominence and the solar flares are both types of eruptions that take place on the Sun. We said that the prominence looks like a ribbon of glowing gases that leaps out of the chromosphere into the corona, and this is how it looks like. On the other hand, the solar flare, we said that it's an explosive eruption that looks like volcanoes, and along with the extra bright light, solar flares also give off other forms of energy. This energy is so powerful, and it's powerful enough to interrupt radio and satellite communication on Earth. So by this, we finish reviewing um, the Sun, its layers, and its two types of eruptions. We are going to start now talking about constellations. Actually, if we look here at this picture that you have in your book, page 274, we can notice that it's just stars that make up a specific shape or specific pattern. So many times you look at the sky and you see, oh, this looks like a bear, for example. Or these group of stars, when they are joined together, they form a different shape. So this is what is called a constellation. So constellation is a group of stars that forms a pattern. As simple as this. So today scientists divided the night sky into 88 constellations. So we have 88 constellations. One of the star patterns or the constellations is called the Little Dipper. The Little Dipper contains a star called Polaris. Polaris actually is a very important star. If we look here at Little Dipper, so this is the shape, it's called Little Dipper, and this is the star that is called Polaris. Actually, Polaris is very important because it's used in navigation, because it's called the North Star. It's a very hot and large yellow white star. It's located directly above the North Pole. So early explorers used Polaris as a guide to direct them in their travels. So if when someone was lost, uh, he looked at the sky. When he saw the Polaris, he knows that he is heading to the North Pole. That's why Polaris is very important. Okay, please, I want you to stop the video, to pause the video, and answer questions 6 and 7, please. Okay, to move on, so we know that the stars are not always in the same place. They move in predictable ways. Actually, the spinning of the Earth makes the stars appear to move from east to west across the sky. And can anyone tell me why from east to west? Well, that's right. It depends on the movement of the Earth. That's why the spinning of the Earth will control or will make the stars appear to move from the east to the west across the star. So if we looked here at this animation, and if we moved the cursor, so it's 11 p.m. If I do this, you would see two types of constellations. Okay, I know this is very interesting. So these patterns remain the same night to night for thousands of years. Okay? So we can see here the Big Dipper and the Little Dipper. Okay, the stars do not remain stationary in the night sky. They appear to move. Let's watch this video to see how the stars move. So I want you, while watching this short video, to pay attention to the clock here. So this is at 11 p.m. This is the Big Dipper. This is the Little Dipper at the same hour, 11 p.m. Can you see how they are moving? It's 12 a.m., 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m. So actually, constellations do not change position. They look like they move because Earth rotates on its axis. The stars above you seems to move because you are moving. So that's what is actually happening. So if we are here, this is how the Earth is rotating around its axis, and this is why the constellations appear to be moving. So after we're done, I want you please to answer this question. How do the stars appear to move during the night, in addition to the two questions that I assigned 6 and 7 in your book, page 274? Once you're done, send your answers please as a message on Classera. And if you have any question or any concern, please do not forget to send me a message or record it on our discussion groups. Have a nice day.